Hey, so today we're going to do factoring integers, and we're going to talk about prime factorization and greatest common factors. So hopefully some of this is still a bit of a review and nothing too new, but still fun and exciting. So if I wanted the factors of 19, that really means that I want the numbers that multiply to get 19. So if I'm looking at 19, hopefully you know 19 is prime, which means 1 and 19 are really the only two positive numbers that you can multiply to get 19. But you also have to remember that negative 1 and negative 19 will also give you a positive 19. So I want you to remember that a negative pair of factors can always be the factors of a number, whether it's 19 or 24, 36, 48, or even 4, negative 2 times negative 2. But for now, we're only going to concern ourselves with the positive. We're going to focus on those positive integers. So if I want the factors of 64, I can look at them in pairs, and that's a good place to start. And so I could look at 1 and 64, or 2 and 32. 4 does not go into 64. Silly Miss Danza. But, oh yes it does. 4 goes into that 16 times. I thought so. And then 8. And 8 goes into 64. 8 times, because 8 times 8 is 64. So those are the factors of 64. But what if I wanted the prime factorization of 64? I do apologize for my handwriting there. This is FAC, factorization of 64. So let's first make a little factor tree. Hopefully you've done that. And I'm going to go with that first factor pair that we just wrote down, which was 3 or maybe 2 and 32. So 2 and 32. 2 is prime. It can go no further. 32, on the other hand, I can continue to break down. So I know that 2 goes into 32. So I'm going to do 2 again. And 2 goes into 32 16 times. So again, 2 is prime, so I'm going to stop with that side, but 16 I can break down to 4 times 4, and then each of those 4s I can break down to 2 times 2. Okay, so the factor tree we get, but the prime factorization of 64, I want to use exponential form. And I want to say how many factors, like which numbers are prime factors, and how many of those I have. So the prime factors themselves are going to be our base. So in this case, we only have 2. So 2 is the base. My exponent is going to be how many times it is a factor. So it's a factor 1, 2, 3, 4, 5, 6 times. So the prime factorization of 64 is 2 to the 6th. So now let's do the prime factorization of 45. Well, 45 is 9 times 5. 5 is prime, so I'm going to stop there. 9, however, is 3 times 3. So now the prime factorization, remember I'm going to do exponential form, and I'm going to use my prime factors as the base. So I have 3 and 5, and then the number of times they appear at the very end, see how this is at the end and these are at the end, is going to be my exponents. So 3 appears twice and 5 appears once. So I can put that 1 there if I want to, but I don't have to. Well, what if I want the prime factorization of 180? So 180, again I can do this a couple ways. I can start however I want. I'm going to do 18 times 10 because I know 18 times 10 is 180, and that's pretty easy for me to do. 10 is not prime, but it is 2 times 5, and both of those are prime, so I'm going to stop that side of my tree. 18 is 3 times 6. 3 is prime, so I can stop there. 6, on the other hand, I have to break down, which is 3 times 2. So, oops. These are the ends. These are my prime factors, which means my prime factorization is going to have, let's see, I have a 2, 3, and 5. Those are all my bases. And let's see, I have 2 times, so it's going to be 2 squared. 3 shows up 2 times, so it's going to be squared. And 5 shows up once. So my prime factorization of 180 is 2 squared times 3 squared times 5. What if I want the prime factorization of 36? Well, 36 is 6 times 6, which is 2 times 3, and 2 times 3. These are my prime factors. That's where everything ends. So the prime factorization of 36 equals 2 squared times 3 squared. So hopefully you wrote that down. 2 squared times 3 squared. That's the prime factorization of 36. Well, how about the prime factorization of 90? Well, 90 is 9 times 10. 9 is 3 times 3, and 10 is 2 times 5. So these are my ends, my prime factors. So the prime factorization of 90 is 2 times 3 squared times 5, because that's how many times they show up. Well, now let's take a look at the prime factorization for 36 and the prime factorization for 90 and see what they have in common. So I've got 36 and the prime factorization of it, and 90 in its prime factorization. So I want to see what they have in common. Well, I noticed that they have 2's and 3's in common. So I'm going to bring down 2 and a 3. But now I want to see how many of those they have in common. So how many 2's show up in both 36 and 90? So here what I do is I take the smallest exponent of that common factor. So over here I've got a 2, and over here I've got a 1. So the smaller exponent is 1, so it's 2 to the 1. Now I'm going to compare the 3. Here I've got 2, and here I have 2. So my exponent for 3 is going to be 2. So this is what they have in common. It's the most that they share. And so 2 times 3 squared, that's actually 2 times 9, which equals 18. And we just found the greatest common factor of 36 and 90. Greatest common factor is the biggest number that goes both into 36 and into 90. We want the biggest number that goes into both of them. So to do that, we find the factors that they share. So here we had the 2 and the 3, and then we find their smallest exponents. So here we had the 1 and the 2, and that's our greatest common factor. So let's try another one. Alright, so what if I want the greatest common factor of 42 and 56? So the first thing I need to do is my prime factorization of 42 and my prime factorization of 56. So 42 is 2 times 21, and remember, you can break this down however you want. As long as you're using real factors and you go all the way until you get down to the primes, it doesn't matter if you do 2 times 21 or 6 times 7, however you want to do it. So 21 breaks down to 3 times 7. And now I'm done. I'm at my primes. So the prime factorization of 42 is 2 times 3 times 7. Well, 56 is 2 times 28. 2 is prime, so I'm going to leave that. 28 breaks down to 2 times 14. 14 breaks down into 2 times 7, and those are both prime. So I have 2 as a base, 7 as a base, and 2 appears 1, 2, 3 times. So 2 to the third times 7 is my prime factorization for 56. So now to find their greatest common factor, I need to find out what they have in common. So if I look, they both have 2 as a base, and they both have 7 as a base. And now that I've found the bases they have in common, I look for the smallest exponents. So here I have 3, here I have 1, so my smallest exponent is going to be 1. And then 7, I have 1 and 1, so the exponent for 7 is going to be 1. And 2 times 7 is 14. So the greatest common factor of 42 and 56 is going to be 14. So now you can go and complete the check-in for this video.